Hi, I'm Bob. Welcome back to the 5 Minute Econometrics, a tutorial on basic econometric concepts and estimation ideas. Today, we will answer a question about the OLS estimate in multiple regression, such as a model with two explanatory variables x1 and x2. When will the coefficient on x1 be the same as from a simple regression of y on only x1? In a general case, we can write the model in matrix form. The explanatory variable matrix X contains k explanatory variables. We can write X into two sets, x1 and x2. We examine the condition under which the estimates from the multiple regression will be the same as from the partitioned regression with only x1 or x2 as the explanatory variable. If we pre-multiply the model by M2 on both sides, the equation still holds. M2 is the residual maker matrix. According to the definition of M2, when it times x2, the result will be 0 because the residual from the regression of x2 on x2 is 0. M2 times epsilon equals epsilon because x2 is not correlated with the error term by assumption. Then we have equation 1. We can write the OLS estimator beta 1 hat from equation 1 directly. We observe the expression and find that if M2 times x1 equals x1, then the OLS estimator will be the same as in a partitioned regression of y on x1. We write out M2 and find that only when x2 prime times x1 equals 0, beta 1 hat is the same as in the partitioned regression. This condition implies that x1 and x2 are not correlated with each other. This result is called the orthogonal partitioned regression theorem in William Green's textbook, Econometric Analysis. We can also show this result from the omitted variable idea. We write the population model with two sets of explanatory variables, x1 and x2. Suppose we only have data on x1 and run a partitioned regression of y on only x1. The omitted variables x2 will be put in the new error term new. After we write down the matrix form OLS estimator beta 1 hat, we substitute y with its real relation expression. There are three terms. The last term is 0 by the zero conditional mean assumption. The first term is beta 1. The middle term will be 0 only if x1 prime times x2 equals 0. Now we can answer the question at the beginning of this topic. Only if the explanatory variables x1 and x2 are not correlated with each other will the OLS estimator beta 1 hat from the multiple regression be the same as that from a simple regression of y on only x1. Let's verify this result in Stata. In real life, it's tough to find two variables that are not correlated with each other. So we use simulated data to show the orthogonal Partitioned Regression theorem. We can generate pseudo-random numbers in data and use the data generating process to create variables with particular properties. We first set a seed to any number we like so that we can get the same sequence of pseudo-random numbers each time we run the program. Then we set the number of observations. Next, we generate variables with random numbers. The error term epsilon is from the standard normal distribution. The explanatory variable x1 also contains random values from the standard normal distribution. We generate another explanatory variable x2. It is from the random uniform distribution. The way we generate x1 and x2 ensures that they are not correlated to each other. We can generate another explanatory variable x3 that equals x1 plus a random value from the uniform distribution. By doing so, x3 is correlated with x1. Then, we generate the outcome variable y. This is the real relation between y and x. Y is a function of x1, x2, and the error term epsilon. We set the true parameters. The true coefficient of x1 is 2, and the true coefficient of x2 is 3. We can set any numbers for the true parameters. We first regress y on x1 and x2. Second, we regress y on only x1. Third, we regress y on only x2. We find that the estimated coefficient from the multiple regression is the same as from the simple regression. The estimated coefficient on x1 is 2, and that on x2 is 3, either in multiple regression or in simple regression. That is because x1 and x2 are uncorrelated or orthogonal. So we verify the orthogonal partitioned regression theorem using simulation. If the two explanatory variables are related, the OLS estimate will differ between the multiple and simple regressions. We generate another outcome variable y2. When we regress y2 on x1 and x3, we have the OLS estimated coefficients on x1 and x3. They are very different from the simple regression of y2 on only x1 or x3. The reason is that the two explanatory variables x1 and x3 are correlated with each other by the data generating process. The orthogonal partitioned regression theorem does not hold. Thank you very much for watching this video. See you soon on the next topic. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.